Okay, good morning, class. One day when you people are out in the real world, you're gonna say, yes, so why didn't I just do it? No? Remember those words. But anyway, let's do this. Let's do what's good for us. So this is the examples for further examples of trigonometric equations. The examples for exercise 7.12. Exercise 7.12 is on page 249. 249. However, these examples is on page
248.
Okay. So further trigonometric equations. So in example 1, you ask to solve the following equation for alpha as cos of alpha is equal to cos 3 alpha is equal to sine of alpha, where alpha is greater than or equal to negative 90 but less than or equal to 90. So this is a restricted domain. People cannot do what I did yesterday. Can I divide both sides by sine theta? Why not? Oh, sorry, cos theta. Cos 3 theta. Because the sine of a cos is 10. But could I divide both sides by cos 3 theta and get 10 on the one side? No, why not? Because the angles are not the same. It's supposed to be alpha, not theta. No? So, I can't do it. How else could I get those trigonometric ratios the same? Here we go. Cos 90 minus alpha. Can you see that, people? Because if you got, say you got cos of A equals cos of B, then what can we say? A has to be equal to B. But then of course there's other factors involved, like the k times 360 and all of those things. Not so. But if you got 10 of alpha equals 10 of beta, what can we say? Alpha is equal to beta. Not so, with all its general solution items that comes with it. But you guys understand? So if I get the same trigonometric ratios on either side, I can just drop the trig ratio. Does it make sense? Because cos is a function, and whatever whatever effect cos have on that angle will have the same effect if this is cos on the other side of the angle as well. Okay, you guys understand that? So what we're going to do is, as you said, I'm going to replace sine with cos of 90 minus that angle. So it's cos 3 alpha, cos of 3 alpha is equal to cos 90 minus this angle. I could have said 90 plus, okay, but then it might be at times negative and all of those things. That's why I always go into the first quadrant. Whatever the angle is, I say 90 minus. Why? Because then it doesn't affect the sign on the trig ratio. You guys understand that? It doesn't affect the sign. So, as in the first quadrant, all is positive. So you all agree I can drop this here now, as I showed you earlier. Not so. So I now can say reference 3 alpha is equal to 90 minus alpha. And as we did before, we do not divide by 3 alpha. We take the alphas over until we take it to its quadrants. Okay. So how do I take it to the quadrant? Which quadrant? We ask ourselves, which quadrant is cos? Positive. You see that, people? Just before I took all cos on either side. In which quadrant is cos positive? 1 and 4. Let's go with quadrant 1. Let's go with quadrant 1. How do I get into quadrant 1? Just the angle. So it's 3 alpha is equal to 90 minus alpha plus k times 360. Not so. Or quadrant 4. What do we get in quadrant 4? 360 minus. It's going to be 3 alpha is equal to 360 minus this angle here, which is 90 minus alpha plus k times 360. There's a common made error. We learners don't put that in a bracket. Why must it go in a bracket? Because there is more than one term following a negative sign. You see that, people? So what does this give us now? We get over the equal sign. So 3 alpha plus alpha is 4 alpha is equal to 90 plus k times 360. Divided by 4, so alpha is equal to, that means 225, 2.5. Let's check there quickly. Okay, we just pull up the calculator anyway. Okay. So 90 divided by 4. So of course 22.5 degrees plus k times 90. So dividing throughout by 4. Can I add these, people? Unlike those. Okay. The other end, which is quadrant 4. You get rid of the bracket, so it's going to be 3 alpha equals 360 degrees minus 90 plus alpha plus k times 360. Okay? Take everything to one side, the equal sign. So 3 alpha minus alpha is 2 alpha is equal to 360 minus 90 is 270 plus k times 360. So what do I do now? Divide by 2. So alpha is equal to 135 degrees plus k times 180. What must I not forget to add? K is an element of. What was that the question? Was the question to write a general solution? No. We have a restricted domain here. Not so? As you can see, the alpha angle must only be between negative 90 and 90 degrees. So let's pull that down a bit. And now we list. You can now say that alpha is an element of, or it belongs to the set of. Where do we start? We start with 0 here. Not so. Put 0 in here, what do I get? 22.5 degrees. If I put 1 in here, I'm going to get 112.5, which is outside. You see that, people? Outside of what? Outside the given domain. If I add 90. 112.5. So what do I do now, people? Negative 1. So I got negative 1. So it's minus 90, in other words. You give us negative 67.5. Is that within this given domain here? Yeah. That's negative 67.5. What will happen if I put minus 2 in there? It's going to be outside this given domain. Do I write that down? No. So that branch I've exhausted now. I've used all the solutions in that branch. So what do I do on the side? I start with 0 again. Okay? I put 0 in there, what do I get? 135, which is outside already. What will happen if I put 1 in there? I'm going to get 215, which is even further out. So if 0 doesn't work, 1 won't work, 2 won't work, and so on. However, we can put minus 1, so 135 plus negative 1 times 180. Negative 45. parentheses within that given domain. Can you see that? We're going to go with minus 2. That's going to give you negative 225, which is further out. You guys understand? So if minus 2 don't work, minus 3, minus 4, and so on. It didn't work. So those are my solutions. Okay? Yes, Michael?
So can you please explain the first step?
Sorry?
Can you please explain the first step?
The first step from there.
Yes, sir.
Okay, so what we need to get is, because yesterday what we did was we said sine over cos was tan, but then the angles were the same. However, here you see that if I had gotten a cos here or a sine there, then I could have dropped the sines. Or in this case, I dropped the causes. Because they are functions, it has the same effect on that angle there. Okay, so we can, if we take arc cos on that side, arc cos on that side, it cancels out anyway. You remember from grade 10? When we had arc cos cos of 50, what was that answer? Jeez Louise. That is why I don't understand. It's 50. What is arc sine? Sine of 10 degrees. It was 10 degrees. What was arc tan? Tan of 89 degrees. 89 degrees. So if I got the same trig ratio here as I have there, and I go arc cos on either side, what's going to happen? It will cancel. Then I'm just left with the angle. Okay? And then, because it's a reference angle, I take it whether it's positive or negative. Okay. There's another one coming up now like this, I'm sure. Yep. Example 2. Example 2 is on page?
Same page.
Same page. Same page plus 1. Alright. Solve the equation sine of theta plus 20 is equal to cos of theta, where theta is an element of negative 182, 90. Again, it's a restricted domain. So what do we do first? We work out our general solution first. Okay. So what do we do here, people? Can I divide both sides by cos theta? And then get tan on the one side? No. Why? The angles are different. So what I do, people, I make it a rule to keep the first one, change the second one. Okay? If you, that kind of girl that want to go the other way around, you want to change the first and keep the second, I know how to mark it in you. Okay? So if you're going to give you the same answer, you make no mistakes. Alright, so what am I going to do is I'm going to change the cos. So it becomes sine of theta plus 20 equals what? Sine of 90 minus theta. You see that? So if I say arc sine of theta plus 20, what am I going to get? If I'm going to say arc sine sine of theta plus 20, what would that be? I just showed you earlier on. It will give you the same. So they strip each other, they cancel. And what if I say arc sine of 90 minus theta? 90 minus theta. And this is called your reference angle. Okay. So what do I do now? I take it to the quadrants. The question we ask ourselves, in which quadrant is sine? Positive. You as a negative, I would ask you it's negative. In which quadrant is sine positive? First and second. You see that, people? How do we get into the first quadrant? It's going to be theta plus 20 equals 90 minus theta plus k times 360. Why 360? The period on the sine graph is 360. Or quadrant 2. How do we get into quadrant 2? 180 minus. So it's going to be theta plus 20 equals 180 minus 90 minus theta plus k times 360. Okay. The theta over the equal side, the 20 that side. What's theta plus theta? 2 theta equals 90 minus 20, 70 plus k times 360. Divided by 2, so that will be 35 degrees plus k times
180.
180. Right. You see on the side. People, if I get an answer of 5 is equal to 0 in an equation in grade 9, what did we say? 5 is equal to 0. Huh? No, not identity. We need something an identity. If 0 is equal to 0, that's an identity.
So don't you say 5 is to 5?
Identity, that means to say all true values for x. X is an element of all real numbers. Okay, but if you're looking at this one here, if you got a number is equal to 0, then this would be no solution. Or no true values for x. Okay. Can we ever have a number, let's say 5 bananas equal to no banana, or 5 apples equal to no apples? No, that was non-existent. They won't find a case like that. No? So if a number is equal to 0, then there's no solution on the sum, as you will see now in this case. Okay? Because if I multiply this out, what do I get? I get theta plus 20 equals 180 minus 90 plus theta plus k times 360. So it's going to be theta minus theta. Can you see that? It's going to give you 0 then. It's equal to 180 minus 90 is 90 minus 20 is 70 plus k times 360. Can you see it? 0 is equal to 70. So what do I say here? No solution on that branch. There's only one case, or one branch on this solution. You guys understand? Okay. What must I not forget? The case in element of integer. But people, what we have here? We have a restricted domain. So we say theta is an element of. So we start with 0. If I put 0 in, I get 35. If I put 1 in, it's going to give you 2 to 5, no? Which is outside. Put minus 1 in, you get negative 145, I think. Negative 145. What will happen if I put minus 2 in? Outside. That's where I stop. Okay. See, any confusion there? No issues. Alright, so with that, you should have been able to have done exercise 7.12. I know some of you worked ahead. Was there any problems with 7.12? You didn't work ahead this time? Nobody? Okay, so that we'll call that to a close. The full lesson can be found in the description box below. We have actually done all the odd numbers of exercise 7.12.